So, onto a teaser. Well, let's look at the mechanical system like that. There's some car frame, and then these are axles, and these are wheels, and this red wheel touches the blue one here and here. And then what happens if we start? Let's see if it will work. Sometimes it will. And you should see an animation of this. So when this is going around, if these are touching at these points, now it's not going that good. But the velocities of relative to this frame of this line and this ring is the same. So the velocity of this ring is moving a little bit faster because the radius is different. And well, you can build it of Lego, and then you can play around with it. But the thing is that I wanted to show you what happens if you stick this thing in between two walls and start moving. Let's say the upper one, and then wait a little bit more, and then you see it's moving. And now so I want you to think like, okay, so this could be the ground, and this thing up here moving could be the wind. And what you see is going on, if the wind is going that way, this thing is going the other way. So that is going, you could say, upwind. And you can build it out of Lego or anything. Really, it's a simple mechanical device. So that's a teaser. And what you can do if you have more Lego, or you can carve some out here, so you can actually change the gearing that way. And now you can see that you're not moving the roof as much, but it's going much faster relative to the roof. So so the question is here: can you do this between any two media and not just two walls? And I'll try to get into that now. Yeah, well, another teaser here is, yeah, well, can it be done? Yeah, well, I just wanted to show you this is last year's car, and yeah, well, what you can't see is that the wind is actually coming from this direction, so it can be done, and you probably knew that when I said there was a contest. But that was last year's car, and they did go a little bit faster than what we just showed. So this is how the wind race cars look like, and what I'm going to be doing now is to try and describe to you the theory in a very general manner. So that was in Holland last year, where we got beat by that car, by the Stuttgart team. So the energy conversion mechanism at play, I think that's the key in a car like that. Is yeah, well, let's look at the very basic stuff here. There's a mechanical work. This is a little bit of mechanical work. There's a force, and then there's a displacement vector. And the dot product of these two is mechanical work. And if this is the size of the force and the displacement vector, then and this is the angle between them, then you can write it like this too. So if you take the time derivative of something like that, you end up with time derivative of work is power, and then the time derivative of force, well, force times displacement is velocity times the force. So, and this is the ideal relation. This is without losses. So this is the best you can do if you want to make a power. So then this is the best value you can get. Or if you want to make a force from a power, like in the propeller case, so this is the ideal relation. So this is from basic principles. So this is a relation between power, force, and relative velocity between two things. So the other thing would be Newton's second law. I'm sure you know that. This is a vector version of it. Force equals mass times acceleration. So I put an x here. That's, let's say x is the direction you want to go in. So this is what we have. So the thing is, when you're at top speed, you don't have any acceleration. So this term here is 0, and therefore the sum of forces should also be 0. So forces should balance at top speed. Let's look at the thing from the ground. This is now a wind turbine car. You're standing on the ground looking at it, and what you have there is, well, the wind is coming at you at this velocity, and then this is the velocity of the car, and from there's a wind hitting this rotor. From this there's a thrust. There's a thrust connected to making the power that you want to make on this one. So there's a thrust there, and then from the power you make here, you may lose some of it, and then the thing that's left when you get down to the rear wheel is the power you have to make it from divided by the velocity difference between the car and the ground. This is the thing you can make to a propelling force forward. And then there are some losses. Usually there will be a drag on the car. All of this vehicle that is not the rotor, that's the drag here, and then you might have even a rolling resistance down here, which scales with the mass of the car. So if these are the forces, let's see here, they should match up. So this, all the forces in this direction, that, and that, they are here now, and they are just as big as the other one. Then you've got this is a constant top speed. So this is one of the basic things we have to do when we put up theory for the car. That was this one. And then energy flow balance. If you make something on the rotor, then you can use all of that to propel the car. But usually you don't have all that, because you'll probably use some of it. If this is what you make on your rotor, this power, then you lose some of it in the transmission. It gets to heat and noise, which will get to heat in the end. But this is what you can use for propelling yourself. So you lose something in transmission. So this is accounting now for the forces, which have to balance, and then the energy through the system. So you can write it like that, or have a schematic of it. It doesn't look much like a wind car, but if you imagine sitting on the car, then did I show us that? Yeah, well. So this is the vehicle control volume. You have two media. One which I call the generation medium. This is where you generate your power. Okay, the power from here, and the force on the vehicle from that medium, and that's from everything connected with the generation medium. For the wind turbine car, that's the air. So this is the total force from the air, thrust and drag. And then this is then the ground. If you sit on the vehicle, the ground is moving towards you with a slower speed, and this is where you use your power. And some of the power you generate here, some of it get lost because there's a transmission efficiency less than 1. But the thing is that the force you have to react to the other medium with should balance exactly this one. This is what you have at top speed. So this is really how it works. Top speed, yeah, this force should be equal to this force, and directions swapped. And then accounting for you produce something, then you produce something at a generation, and then you lose a part of it in the transmission. This is what you have for propulsion down here.